rod of length 4 meters with the density given by 1 plus x squared kilograms per meter. So this is the unit of your density, is positioned along the x-axis with the left end at the origin. Now we're told to find the total mass of the rod and to find the center of mass of the rod. So again, the advice I usually give is anytime you're told to solve any question like this, the very first step you want to do is you give a diagrammatic representation of the problem statement. That's what you do. So first and foremost, you're going to start by drawing the x and the y axis. So this is my x axis here, and this is my y axis. Now what I've been told is that a rod of length 4 meters with a density of this is positioned along the x-axis. That's the first thing I need, and then with the left end at the origin. That's the next statement I need. Now when I position this such that the left end is at the origin, and we've been told that it has a length of 4 meters and it is along the x-axis, so I could just sketch this. So this could just be the rod we are talking about here. So anyway, this is my rod. This is my rod here. So it's really something fancy, but you already have an idea of what we're talking about. So the length of the rod is 4 meters. That's the length of the rod. So that tells me that if here is 0, then definitely here has to be 4 on the x-axis. Now we're done with that. We also told that the density of the rod is 1 plus x squared kilograms per meter. So the density we are given, that's the density of the rod. The density of the rod is 1 plus x squared kilograms per meter. 1 plus x squared kilograms per meter. Now we're told to find the total mass of the rod. Now to find this, there is a mnemonic that's a very good way to solving problems like this. So what we're going to do is we're going to start by so the mnemonic is this. So you slice, you sum, and then you take limits. So what we're going to do is you start by slicing. You slice the whole region. When you slice all of them, so let's say you slice them into equal halves or equal parts, then you pick just one of them. So let's say we pick here. So we're going to have something like this. So what we're going to do is we want to find the total mass of the rod. Now if we can find the mass of this slice here, then what we're going to do is, from our knowledge of the mass of the slice here, we'll find the total mass. Now to make our computation, to make it accurate, we'll take limits to find the exact value. So anyway, when we bring this out, let's say the length of this, let's assume the length is delta x. Now if the length is delta x, let's bring this out. So what you're going to have is you're going to have something like this. So this is our slice that has delta x. Let me change the color. I'm not sure if this color is very bright enough. So it has a length of delta x. Now I want to find the mass of the slice. That's the first thing. I want to find the mass of this slice. Now how do I find the mass? From the formula of the density, we've been told that the density is kilograms per meter. So that tells me that my density is the kilogram, that's mass, per meter, that's length. So that tells me to find the mass, I need to cross multiply. So the mass equals the density times the length. So that's the formula for the mass. So that tells me to find the mass of the slice. So that is to say, the mass of the slice, which is the change in m, equals, so the formula is the density, and our density is 1 plus x squared, then multiplied by the length of the slice. Now the length of the slice is delta x. So that tells me that the mass of the slice is just going to be 1 plus x squared multiplied by delta x. Now this is the mass of the slice. So this is the first thing we've done here. We've taken the slice, we found the mass of the slice, then the next thing is you sum. So this is the first step. So the next step is you want to find the total mass. So the total mass is just going to be equal to the sum of all the small slices which you found one of them. So the sum of all the slices is going to be the sum of all of them. That is this times delta x. So this is the total mass. But we want to find the exact value. That's the exact mass. So to find the exact mass, that's the exact mass. It's just going to be the limit as the change in x tends to 0 of the whole total mass. That's 1 plus x squared multiplied by delta x. Now whenever you take limits for a sum, two things change. So the first thing that changes is the sum, and the next that changes is delta x. So in other words, what I meant there is the limit as delta x tends to 0 is just going to be the integral. So the sum here has changed to an integral sign. So you have 1 plus x squared. Then the delta x here also changes to the x. So you see two things changes. And then all we need is the range of x. So from here you can see our x is going to run from 0 to 4, because the x runs from here to here. So x runs from 0 to 4. So this is just going to be from 0 to 4. And when we find the integral of that, that's just going to give you, so this is the integral of 1 plus x squared. So the integral, when you integrate 1, you have x, plus when you integrate x squared, you have x cubed divided by 3. This is from 0 to 4. And this is just going to give you 76 divided by 3 kilogram. So this is your total mass. So that's the first question we've answered. Now the next question says find the center of mass of the rod. The center of mass of the rod. So I'm going to call that B. The center of mass of the rod. So let's call the center of mass, let's denote it by this symbol here. Now you recall that the formula for the center of mass is the total moment divided by the total mass. The total mass. So this is the formula, and then we've already gotten the total mass here. So let's say our total mass is we had the total mass to be m, and the formula for moment. So you recall that the formula for moment is the product of the displacement times the mass. That's it. So anyway, the formula for the total moment is just simply the integral of x times the density, which is del of x dx, then divided by the total mass. The total mass. Let's write it to the total mass. Now what you'd observe is the symbol I wrote down here is still the same thing as what you have here. In other words, what I meant is this is x, which is the total moment. This is x, you can see that here, and then the mass. So you recall that the formula for mass, like we have up here, the formula for mass is density times length. That is the density times the change in x. The density times length. That's mass. So you can see here, this is the density times the length. So this is also representing mass. So it's still the same thing. So this is a very good way to recall the formula in case you forget the formula. So just know what you have here is x, and what you have here is just mass. It's because it's a continuous mass density. That's why we have to take the integral of that. Okay, anyway, we have this. So the next thing is let's just plug in our values. So this is going to be the integral of, so our x is x, and the del of x, which is the density. So we go back here. So the density is 1 plus x squared. So we come back here. So we have 1 plus x squared. Then the x divided by, now the total mass we've obtained that to be 76 divided by 3. So write that down, 76 divided by 3. So again, we need our limits of integration. Now we come back to the problem statement. What you have here is it goes from 0 to 4. So that's going to be from 0 to 4. From 0 to 4. So simply when you do this, you're going to have, when you find the integral of this, which is quite simple like we've done in the previous videos, this is just going to be 72 then divided by, so what we have here is 76 divided by 3. So, and when we simplify this further, what we would have is going to be 54 divided by 19, so which is actually approximately 2.842 meters. So you can just say 2.84 meters, 2.842 meters from the origin. So this, you could just say 2.842 meters from the origin. Anyway, this is the solution to the problem.